For nearly a century, a single skull sat in a museum drawer in London carrying a secret nobody could actually prove. It looked ancient. It looked primitive. Scientists guessed it might be 500,000 years old, maybe older, a distant relic from deep in humanity's family tree. Then, using tools that didn't exist for most of the 20th century, researchers finally cracked open that mystery. And the real number that came back wasn't just surprising, it rewrote the entire timeline of who was actually walking around Africa at the exact same moment our own species was being born. This is the story of the Broken Hill skull, sometimes called the Kabwe skull, and why a piece of bone pulled out of a Zambian mine over 100 years ago might be one of the most important and most misunderstood fossils in the whole story of human origins. Before we get into it, if you're into stories like this one, deep dives into human evolution and the discoveries still reshaping it, take a second to subscribe. It genuinely helps this channel keep telling stories exactly like this one. The story begins in 1921 in a place then called Broken Hill, a booming lead and zinc mining town in what was, at the time, the British colonial territory of northern Rhodesia. Today, that same town is called Kabwe, and it sits in central Zambia. Deep inside the mine, workers were tunneling through limestone caves searching for ore deposits when a Swiss miner named Tom Sviglar stumbled across something nobody down there was expecting to find, a skull. Not a modern skull, something older, heavier, strange. The brain case was low and sloped. The brow ridges above the eyes were massive, thick shelves of bone jutting forward like the edge of a helmet. It didn't look like anything that belonged to a person from the 20th century, and it certainly didn't look like it belonged in a mine. The skull eventually made its way to a scientist in London named Arthur Smith Woodward, one of the leading paleontologists of the era. Woodward examined it carefully and concluded that this wasn't simply an unusual human skeleton. It appeared to belong to an entirely new species, one nobody had ever formally identified before. He named it Homo rhodesiensis, after the colonial territory where it had been found, and in doing so, he had just handed the world something remarkable, the very first early human fossil ever discovered on the entire African continent. That detail matters more than it might sound like at first. At the time this skull was pulled out of that mine, almost nobody in the scientific establishment believed Africa was where humanity's story actually began. The dominant thinking of the era pointed toward Asia, and later toward Europe, as the likely birthplace of the human lineage, based largely on fossil discoveries being made in those regions at the time. The Broken Hill skull quietly complicated that assumption, planting a flag deep in Central Africa and forcing scientists to at least consider that the picture might be more complicated and more African than they had assumed. Over the following decades, as more fossils were unearthed across the continent, and as the fossil record slowly filled in, researchers began reclassifying the Broken Hill skull. Today, most paleoanthropologists place it within a species known as Homo heidelbergensis, a robust, thick-boned, heavy-browed population that is generally thought to have spread across Africa and parts of Europe, often discussed as a possible common ancestor to both later Neanderthals in Europe and eventually, in some models, to our own species, Homo sapiens, evolving separately within Africa. Anatomically, the Kabwe skull is a strange, fascinating blend. It has the low, sloping brain case profile, the heavy brow ridge, and the pronounced bony ridge running along the top of the skull that you'd expect from a genuinely archaic hominin, features that echo even older species like Homo erectus. But it also has a surprisingly large brain case, measuring somewhere around 1,300 cubic centimeters, comfortably within the range of a modern human brain, and a face that's noticeably flatter and less jutting than you'd expect from something so seemingly primitive. It's a skull that seems to be caught, quite literally, between two different chapters of the human story. And there was something else buried in that fossil too, something almost unbearably human. 10 of the skull's upper teeth showed clear signs of cavities, some of the very oldest confirmed dental cavities ever found in the human fossil record. Researchers studying the skull have suggested this individual may have ultimately died from an infection connected to that dental disease, or possibly from a chronic ear infection that spread through the skull. It's a small, oddly intimate detail, a reminder that behind every ancient bone is a creature that once lived, ate, suffered, and eventually died, exactly the way we do. But here's where the real mystery of this skull begins, and it's not really about anatomy at all. It's about time. For almost the entire 20th century, nobody could actually say with any real confidence how old the Broken Hill skull actually was. And the reason for that uncertainty is almost as remarkable as the skull itself. The cave system where the skull was originally found no longer exists. It was mined so aggressively, blasted apart, and hauled away in the pursuit of lead and zinc ore that the entire site was eventually quarried into oblivion. By the time scientists fully appreciated just how significant this fossil actually was, the physical context surrounding it, the layers of sediment, the surrounding rock, everything that would normally let researchers pin down an accurate date, had been permanently destroyed. That left generations of scientists working almost entirely from guesswork. Early estimates placed the skull at somewhere between 500,000 and 700,000 years old, based largely on its primitive-looking anatomy and rough comparisons to other fossils from similar time periods elsewhere in the world. For decades, that assumption held. The Broken Hill skull was treated as an ancient, distant branch of the human family tree, a relic from deep prehistory, safely tucked away in a chapter of the story that had closed long, long before anything resembling a modern human ever walked the earth. Then, using techniques that simply didn't exist when this skull was first pulled out of that Zambian mine, a team of researchers led by geochronologist Rainer Grun at Griffith University decided to try something different. Rather than relying on the destroyed cave site for context, they turned directly to the fossil itself and to fragments of associated animal bone that had been collected alongside it back in 1921 and preserved in museum collections ever since. Using a combination of uranium series dating, which measures the slow, predictable decay of radioactive elements that seep into bone over time, and electron spin resonance dating, which measures how radiation exposure gradually alters the structure of tooth enamel. The team was able to build an entirely new direct estimate of the skull's true age, completely independent of the lost cave stratigraphy that had stumped researchers for 100 years. The results, published in the journal Nature, landed like a genuine shock across the field of paleoanthropology. Instead of the 500,000 years many researchers had long assumed, the new analysis placed the Broken Hill skull at approximately 299,000 years old, give or take about 25,000 years in either direction. In other words, this individual likely lived somewhere between roughly 275,000 and 325,000 years ago, a number dramatically, almost unbelievably younger than what scientists had assumed for the better part of a century. Sit with that number for a second, because this is where the story stops being a simple correction to a fossil's age and starts becoming something genuinely unsettling for the whole timeline of human evolution. To put roughly 300,000 years into some kind of perspective, that's a stretch of time so long that it covers nearly the entire recorded existence of our own species, Homo sapiens, from its very earliest known fossils right up through today. And somewhere within that same enormous window, this older, heavier-browed population was still very much alive and thriving in Central Africa, not as some kind of leftover from an earlier chapter that had already closed, but as an active, ongoing participant in the same broad era of human history that also produced us. Around that exact same window of time, roughly 300,000 years ago, give or take, a completely different set of fossils on the opposite side of the African continent was quietly rewriting the story of our own species. In Morocco, at a site called Jebel Irhoud, researchers had uncovered fossils that were eventually identified as the oldest known remains of Homo sapiens ever found anywhere on Earth, also dated to roughly 300,000 years ago. For years, those two discoveries sat in completely separate corners of the scientific literature, treated as unrelated pieces of the puzzle. But once the Broken Hill skull's true age was finally pinned down, those two stories suddenly collided. If the math holds up, and every review since has continued to support it, then the archaic, heavy-browed, primitive-looking population represented by the Broken Hill skull wasn't some ancient, long-extinct ancestor safely buried deep in humanity's distant past at all. It was a contemporary, a population that was still very much alive, still walking across the African landscape, at the exact same moment that early members of our own species were already emerging, thousands of miles away, on the very same continent. That reframes everything about how we should think about this fossil. Rather than functioning as some kind of missing evolutionary rung on a tidy ladder leading directly up to modern humans, the Broken Hill population now looks a lot more like a side branch, a distinct separate lineage that had already diverged from the line eventually leading to us, but that continued surviving, adapting, and persisting in its own corner of Africa for tens of thousands of years after that split had already happened. Rather than replacing this older population in a single clean sweep, early Homo sapiens appear to have shared the African continent with it for an extraordinarily long stretch of overlapping time. And Broken Hill isn't even the only piece of evidence pointing toward this same unsettling picture. Around that same rough era, southern Africa was also home to another strange, previously unknown hominin species called Homo naledi, discovered inside a nearly inaccessible cave system in South Africa, and eventually dated to somewhere in a similar general range, tens of thousands of years on either side of that same 300,000-year mark. Homo naledi had a startlingly small brain, barely a third the size of a modern human's, combined with surprisingly modern-looking hands and feet, an anatomical mix that stunned researchers when it was first announced. Put all of these pieces together, the ancient, robust Broken Hill population in Central Africa, the small-brained but dexterous Homo naledi in the south, and the earliest emerging Homo sapiens up in the north, and you get a genuinely startling picture. Roughly 300,000 years ago, the African continent wasn't home to one single evolving human lineage marching steadily toward modernity. It was home to at least three, and quite possibly more, entirely distinct hominin populations, living out their lives across the same vast landscape at the exact same moment in time. For most of the 20th century, the popular version of the human evolution story was told almost like a single, tidy relay race, one species handing the baton smoothly to the next, each one a little more advanced than the last, marching in an orderly line straight toward us. The Broken Hill skull, once its true age was finally revealed, helps demolish that picture for good. Human evolution across Africa during this period wasn't a straight line at all. It was something closer to a crowded, overlapping web, multiple distinct hominin lineages coexisting, diverging, and in some cases, quite possibly interacting, across an enormous and varied continent over an enormous stretch of time. That raises an obvious and slightly unsettling question. If Homo sapiens and this older, more archaic Broken Hill population were both alive in Africa at the exact same time, did they ever actually cross paths? We now know, thanks to genetic research over the past decade, that early Homo sapiens interbred with Neanderthals in other parts of the world, leaving behind small but measurable traces of Neanderthal DNA still present in the genomes of people alive today. Whether anything similar might have happened between early Homo sapiens and the Broken Hill population, or between Homo sapiens and Homo naledi for that matter, remains a genuinely open question. Unlike Neanderthals, no usable ancient DNA has ever been successfully recovered from the Broken Hill skull. And it's entirely possible that Africa's hot, humid climate simply never allowed that kind of genetic material to survive intact across hundreds of thousands of years the way it sometimes has in the colder caves of Europe. Without that genetic evidence, researchers are left working almost entirely from anatomy and geography, and from careful, patient dating work, exactly like the kind that finally cracked open this mystery in the first place. Genetic research over the past several years has actually lent real support to this messier, Pan-African picture, even without any usable DNA ever having been recovered from the Broken Hill skull itself. Studies comparing genetic diversity across present-day African populations have identified patterns consistent with deep, ancient population structure stretching back hundreds of thousands of years. Distinct regional groups that appear to have remained at least partially separated for extraordinarily long stretches of time before eventually reconnecting and exchanging genes. Some of this research has even pointed toward the possibility of a now extinct so-called ghost lineage, an unknown, unsampled archaic population that appears to have contributed a small but measurable amount of genetic material to modern African populations, despite never having been directly identified through any known fossil. It's entirely possible that a population closely related to the one represented by the Broken Hill skull could be exactly the kind of group these genetic studies are quietly hinting at, a lineage whose physical remains researchers happen to have actually found, sitting in a museum collection, while its genetic echo lingers on in people alive today, entirely undetected until very recently. There's also a deeper, more subtle upheaval buried inside this discovery, one that goes beyond simply which species lived when. For decades, many scientists favored a model of human origins, sometimes nicknamed the single origin or East African cradle model. The idea that Homo sapiens emerged relatively quickly and cleanly from one specific region of Africa, likely somewhere in the east, before eventually spreading outward across the rest of the continent, and eventually the entire world. But findings like the Jebel Irhoud fossils in Morocco, combined with this newly redated Broken Hill skull sitting in the heart of Central Africa, increasingly point toward a very different picture, one researchers now sometimes describe as Pan-African in origin. Rather than emerging from one single cradle and then spreading outward, modern humans may have taken shape through a much messier, more distributed process, small semi-isolated populations scattered across many different regions of Africa, evolving somewhat independently, occasionally mixing and exchanging genes with each other, and only slowly, over tens of thousands of years, converging into something we would recognize as our own species today. Under that model, the Broken Hill population doesn't need to be squeezed into the story as either a direct ancestor or a complete evolutionary dead end. It can simply be understood as one thread among many, one distinct population occupying one region of a genuinely vast and varied continent, persisting for an extraordinarily long time, even as other populations elsewhere were independently evolving in different directions. Africa during this period wasn't a single evolutionary highway with one lane. It was something closer to an enormous, sprawling network of separate roads, some converging, some running parallel for tens of thousands of years without ever quite meeting. There's also a very human story tangled up in all of this scientific reclassification, one that has nothing to do with dating techniques or brain size at all. The Broken Hill skull has sat in the Natural History Museum in London ever since it was shipped out of colonial northern Rhodesia back in the 1920s, taken from a mine that was, at the time, operating under British colonial control. largely for the benefit of British commercial interests. In the years since Zambia achieved independence, there have been growing calls from Zambian scientists, cultural officials, and members of the public for the skull to be formally returned to the country where it was actually found. A request that raises complicated, still unresolved questions about who ultimately owns the physical remains of humanity's shared ancestors, and where fossils like this one truly belong, once the science surrounding them has moved on so dramatically from the assumptions under which they were first taken. That repatriation debate has grown noticeably louder in recent years, running parallel to similar conversations happening across museums worldwide about human remains, cultural artifacts, and other materials removed from colonized nations during exactly this same historical period, often without any meaningful consent from local communities. For Zambia specifically, the Broken Hill skull carries a weight that goes well beyond ordinary scientific significance. It represents the first tangible physical evidence that early human evolution unfolded on Zambian soil, discovered at a moment in history when the country itself had no real say in what happened to that discovery or where it would ultimately end up. Museum officials in London have generally cited the skull's ongoing scientific value and the need for continued research access as reasons for keeping it in place, while advocates for its return argue that modern imaging and scanning technology now make it entirely possible to create detailed digital and physical replicas accurate enough for most research purposes, potentially allowing the original fossil to finally return home without meaningfully setting back the pace of scientific study. There's also the question of what all of this means for how museums and universities present this kind of fossil to the public going forward. For most of the 20th century, exhibits built around specimens like the Broken Hill skull tended to present a single, confident label and a single, tidy story, exactly the kind of settled narrative that made the eventual redating feel so disruptive when it finally arrived. Increasingly, museums working with fossils of this significance have started presenting the science itself as an ongoing, evolving process rather than a fixed conclusion, acknowledging openly that today's best estimate may well be revised again as new techniques and new evidence continue to emerge. That shift in tone matters because it helps the public understand that a fossil's classification isn't a permanent verdict handed down once and never revisited. It's simply our current best understanding, built on the tools and evidence available right now, and always subject to being refined or occasionally overturned entirely, the moment better tools come along. There's also a technical dimension to this redating worth appreciating in a bit more detail, because it explains exactly why researchers were finally able to succeed where a century of earlier scientists had failed. Uranium series dating works by measuring the slow, steady buildup of uranium that gradually seeps into bone and tooth material from the surrounding groundwater over long stretches of time, then tracking how that uranium decays into other elements at a known, predictable rate, essentially turning the bone itself into a kind of natural clock. Electron spin resonance dating works a little differently, measuring the buildup of tiny structural changes inside tooth enamel caused by exposure to background radiation over hundreds of thousands of years, changes that accumulate steadily and can be measured with remarkable precision using modern laboratory equipment. Neither of these techniques existed in any usable form back in 1921, and even by the middle of the 20th century, they weren't refined enough to produce the kind of confident, tightly bracketed date that the 2020 study finally achieved. It's a striking reminder that some scientific mysteries aren't really solved by discovering new evidence at all. They're solved by finally developing the tools sophisticated enough to properly interrogate evidence that had been sitting in a museum collection the entire time. It's worth pausing on just how fragile the entire scientific record surrounding this skull really was for the better part of a century. This wasn't simply a case of scientists disagreeing over interpretation. The actual physical evidence needed to settle the question. The layers of sediment and surrounding rock that could have been carefully studied and dated using traditional stratigraphic methods had already been permanently destroyed by industrial mining decades before anyone thought to properly document it. Had researchers not eventually found a way to date the fossil directly, working around that missing context entirely using radiometric techniques applied straight to the bone and to preserved animal remains recovered alongside it back in 1921, the true age of one of Africa's most important human fossils might have remained genuinely unknowable forever, an open question with no realistic path toward ever being closed. It's also worth thinking about just how quickly the accepted scientific narrative shifted once that final piece of evidence clicked into place. For nearly 100 years, the Broken Hill skull was treated with a kind of settled textbook confidence, an ancient, distant relic safely tucked away in humanity's deep past. And then, almost overnight, a single dating study completely upended that comfortable assumption, transforming the same fossil from a distant primitive ancestor into a genuine contemporary of our own emerging species. That kind of dramatic reversal is a powerful reminder that even our most confidently taught chapters of prehistory remain provisional, built on the best available evidence at any given moment, and always vulnerable to being rewritten the instant better tools or better data finally arrive. So the next time you picture the story of human evolution as some kind of tidy, linear march, single file, one species after another, each one a little closer to us than the last, remember the Broken Hill skull, pulled out of a Zambian mine over a century ago, misdated for the better part of 100 years, and finally revealed to be something far stranger and more interesting than anyone originally assumed. Not a distant ancestor at all, but a genuine neighbor, sharing the African continent with our own earliest ancestors at the very moment our species itself was first taking shape. The real story of human origins, it turns out, was never a single straight road. It was always a crowded, tangled landscape, full of different populations, different lineages, and different futures, all playing out side by side, long before any of them knew how the story would eventually end. Thanks so much for watching. If this story fascinated you as much as it fascinated us putting it together, make sure you're subscribed, because there are still countless chapters of humanity's tangled, unfinished origin story waiting to be uncovered, and we'll be right here to walk you through every single one of them. What do you think it means that our own species may have shared the African continent with several other kinds of humans at once? Let us know in the comments below.